Hello everybody, I thought what I'd do is I'd put together a video of kind of like a walkthrough explanation of the coursework specification, because there seem to be quite a few questions coming in at the moment about what exactly certain things mean. So I'm going to start off by setting the context again. So what you see on screen at the moment is the current output of our in-house developed software tool called HipHops, which performs safety and dependability analysis on safety critical systems design, so designs of cars and planes, trains, nuclear power stations, all of that kind of thing. Anything that the failure of such a system would have an impact on life or body. You know, people getting injured, people getting killed, that kind of thing. So what you're seeing on screen at the moment is one of the outputs of the analysis of a steer-by-wire system in a car, and you're seeing a fault tree, which is what the coursework is all about. This is actual output from a design. It's a commercial tool that we sell from the department, and it's in use by various automotive companies, and we also have commercial collaborations with external software companies as well, who package up our tool as like a plug-in engine for some of their design tools. Now we kind of made do with what we had in the view that you're seeing on screen there. It uses a JavaScript, like a JavaScript folder view kind of thing that you might expect in like a file view system or something like that, but we've kind of redesigned it a little bit so that it shows a fault tree. So in this case we've got a steering brake. It starts at the top with an OR gate, and underneath it some basic event nodes here, an AND gate. You can do things like, I don't know, minimize sub-branches and things so you can see what's going on. But this is a fault tree, quite a big one, and what it does is it shows how the failure propagates from these little round dots. These are basic events. They're the root causes of failure in a system, and they're combined through Boolean OR logic and Boolean AND logic, finally up to the top event of the system, which is a system output of some kind. So the failure of the steering brake is caused by the combination of all of these sub-failures, etc. So this is what we have at the moment. It outputs and it views inside a web page, which basically means that it can be viewed anywhere, which we like. I'll show you another tool that is in existence as well. This one now on screen is called Reliability Workbench, but the core functionality of this that we're particularly interested in is their tool Fault Tree Plus. So this is actually showing the same fault tree that I had on screen just a minute ago in our own tool, and as you can see, it's in a different layout. It's kind of like this is the traditional fault tree layout where the branches are all spread out horizontally. As you can see, quite a big fault tree, so it's difficult to see everything that's going on. So let me just zoom in a little bit. Now, as you can see, this is kind of an annoying process. It's not exactly intuitive to use at all. I have to scroll around using the scroll bars. What I was trying to do just there was to drag it across, but I can't do that. It's not kind of using the control metaphors that we are expecting nowadays. And zooming in, I can't scroll in with the mouse. Take my word that I'm trying just now. So it's not ideal to use, but this is a commercial piece of software. It sells for thousands of pounds, and we are looking to find an alternative. Can't speak. Okay, so moving on to the coursework then. The idea of the coursework is to design and implement a fault tree viewer. So just in the window on the left here, we can see a very simple fault tree. It's made up of an AND gate, it has 2 OR gate children, and then each of the OR gates has a basic event child, or 2 basic event children. So this is the view that we're trying to get to, and you can see how this is made up quite simply of arcs and line 2s and move 2s, and it conforms to a basic kind of structure. Now, in terms of the structure of the fault tree, I'm not really concerned with you knowing how to build that at this stage, and which is why I provided in the left-hand view, in the right-hand view, I know my left and my right, in the right-hand view here, I provided a set of objects, and JavaScript objects, such as this one, a fault tree gate, a fault tree node, an OR gate, transfer gate, AND gate, basic event. Now I just keep going. There is extends, which provides the inheritance functionality, and this file example fault trees, which builds from the base objects that I provided. It puts them all together and builds example fault trees such as this one that you can see on the screen at the moment. There are also 2 other example fault trees in there, both the big one that I just showed you in those commercial tools, and another sort of medium-sized one. So, in order to make use of that, right, the key things that you need to be able to do are essentially, with your example fault trees, it is an object. So in your sort of main canvas JavaScript or main JavaScript entry point into your program, you want to build a new fault tree object. So you do this in a new example fault trees object. So you do this in a normal way that you're creating an object, like when you're creating new vectors, etc. So you might say var fault tree examples equals new example fault trees, open and close brackets, semicolon. That gives you your object, your example fault trees object, that you can then call the functions from within. And the important ones that you want are get next fault tree and get previous fault tree. What those will do is they will automatically they will return a fault tree, the next one in the list of fault trees. So if you're on a current fault tree and you just say get next fault tree, it will get you the next one in the list, and it will return you the top node of that fault tree, and because the top node has all of the other fault tree nodes as its children, you basically got the whole fault tree there. So that's how you do it. In order to get hold of a fault tree, you might say, I don't know, var top node equals fault tree examples dot get next fault tree, open and close brackets, semicolon. So that will get you a fault tree that you can work with. Now, a couple of things here. One of them is to note that in order to make those work, you're going to need to include them in your HTML file. Some of you the early birds have noticed that the order matters, so you need to make sure that you define them in this order. So any other JavaScript files that you include as well, in addition to these, you can add after this, but these have to be in this order because fault tree gate depends on fault tree node, which depends on extends, and to set up the hierarchical relationship between the two, and the AND gates and OR gates are inherited children of fault tree gate. So if you have them in this order, then it should not produce any errors for you. Otherwise, there are going to be some errors in the console. So what else is there? Let's see. So you'll notice that although there's this base functionality for creating a fault tree, which is used by our example fault trees object, they all have either blank draw functions or no draw function at all. So this is really what the coursework is about. This is about taking this fault tree data structure which I provided and adding all of the necessary helper functions and the actual draw functions in order to render it onto the canvas, like you can see in the left here. So that is your job. What I'm going to do now is I'm going to walk through a bit of the specification, each part of the specification, for a bit more explanation of the individual sort of the individual parts of it that have points associated with them. So, starting with the AND gate. So at the top of this simple example you can see an AND gate here. It is made up here of arcs to give you the curved parts and line 2's and move 2's in order to give you the straight line parts of it. So those are the functions that you should be making use of in order to draw an AND gate. Moving further down the tree, we'll just start with the basic events at the bottom next. So these are obviously circles, represented by circles, but you've already used the arc command for doing the AND gate, so what I want instead is that the circle should be rendered using the line segment algorithm that we talked about during our second lecture, I think. So you can make up a regular polygon shape using this algorithm, and if you have an increased number of segments then you basically get a circle. So that's what you should be using in order to create your basic event. So moving on to the OR gate, this is made up of slightly more complex curves. You notice they're not regular sort of circle shapes. So what we want for that is to be making use of the Bezier curve functions of the canvas. So if you can get that done, you can draw the OR gate and you get some marks for it. So extra marks, however, will be available for if you generate your own Bezier object in order to draw your Bezier curves. So we went through Bezier curves in the lecture, and there was a demo of that. So you'll be applying that kind of stuff to build your own object for drawing a Bezier curve. So that's for maximum marks for drawing the OR gate. So the next one in, that actually isn't represented in this fault tree, but if I just skip ahead and find one somewhere around here, there we go. That triangle one that you can see on the screen now is called a transfer gate, and in fault trees this is to avoid you having to reproduce branches of the tree that exist in multiple places. So essentially you define it once in the fault tree and then you use transfer gates in order to point to those areas where you have them multiple times. So the transfer gate, obviously you could simply make it using line 2 and move 2's, but what I want is to reuse the algorithm that you used for drawing the circle of the basic event. Remember, it draws regular polygons, so if you reduce the number of segments down to 3 you should get a triangle like this, which you can use to draw your transfer gate. Okay, so next up on the list is, I'm just working my way through the specification from top to bottom at the moment. So transformations. Okay, so all of your drawing should make maximum use of the transformation functions that are provided by the canvas. So in the most case, this will mean using translations and scales, because there isn't really much in the way of a need for rotations for this particular application. Obviously you should be making careful use of save and restore functions in order to make sure that your transformations don't erroneously affect other parts of the tree. But if we just go back to our original mini fault tree, you'll notice that the tree is made up of nodes that are children of other nodes. Now this is kind of important because when you're actually getting your fault tree to draw, essentially all you should need to do is be able to give it a top node, which is provided by the example fault trees, and then tell that top node to draw. the top node knows how to draw itself, and it also has a list of children in it, which you should be able to tell to draw. So, so the process will go something along the lines of top node draw. Top node says, for all of my children, child.draw. And the position of each of the children will be determined by your calculations of where it should be and the appropriate translation and scale functions in order to make it draw in the right place. So, so that would be making maximum use of the transformations. So next up, one size does not fit all. So the idea with this is that in my example here I've defined the I defined the canvas as being a fixed size, 800 by 600, but I also want my canvas to be resizable. At the moment I've kind of shrunk it down so it will fit in this window so that we can see everything, including this code. But actually, if I just drag this across, it's resizing the canvas as I resize my window and keeping the position of my fault tree the same as it was before. But also, if I tell my fault tree to fit to that, it'll fit to the new canvas size accordingly. Okay, so reverse the process. I get my half canvas, and then I can fit my fault tree to size. Okay, so you remember that when I was showing you the fault tree plus tool, one of the annoying things about it was that it was a bit awkward to do zooms. You had to do a zoom in and out by pressing a button, and it did it from a fixed viewpoint, which isn't all that useful either. So the two zoom functionalities that I want in this are, first of all, the ability to zoom in on your canvas at all. So you should be able to do that using the mouse wheel. On the SharePoint site now there is a short tutorial, sort of lab instructions-esque set of instructions that talk about how to add those event handlers to your JavaScript files. And when you hook into those, you will be able to do some zooming. So in this example, I'm just scrolling in and out using my mouse wheel, and you can see that the fault tree is being scaled accordingly. Okay, so the next bit that gets extra marks is a slightly more complicated trick of getting it to zoom in where the mouse pointer is. So before I was just zooming it in and out in the middle there, but if I move my mouse pointer, say, into the middle of this basic event here, and start zooming in, you'll notice that the zoom behavior is now different because it's zooming in about the pointer. So that was centered on the mouse pointer in the basic event there. If I changed it so that I was, let's say, just on the join here of the OR gate and zoom in, there it is, it's all zooming in on that point. So that's a bit more tricky, so you get a few more marks for it. Okay, so I'm zoomed in and I want to see a different part of the fault tree. I want to be able to pan around my fault tree canvas, which I can do by clicking and dragging the canvas. Just moving around. You can see a bit more if I click and drag out in a zoomed out mode. So we need to be able to do that. That's the section panhandler. It should be possible to do that at any zoom level. So in trying to implement this, you may run into complications based on how zoomed in you are, but you ought to be able to handle that. Okay, so next thing is our fault trees of different size. So this is the middle-sized one. We want it to be able to be zoomed to fit automatically the canvas and be centered in the canvas. So you will have to work out how to do that. It's going to be having to work out what the size of the thing is, what the size of your canvas is, and applying appropriate scales and positions, etc. There are extra marks available for this for adding a smooth animation for when the fit to canvas has been applied. So I'm just triggering this with a key press event, and you can see it worked out what the scale needed to be, and it applied it over a set of frames in order to have that nice smooth transition back to the fitted fault tree. Okay, so alternate fault trees. So in this demo I've shown you our 3 different fault trees that have all been provided to you by the example fault tree object. And what I want to be able to do is to cycle through all of these fault trees when you're doing your demo, and to be able to see each one of the fault trees in turn, and apply all of the zooms and pans and fit to screens and all of that sort of thing should be available with all of the fault trees. Now, as you can imagine, particularly with this super large fault tree, which I'll put on screen now, when it's small like this, you can't really see what's what the individual nodes are, or certainly it blurs a little. So what I want to be able to do is to zoom in an area of the fault tree and look at it in some more detail. Now, part of the issue with this is now navigating around the fault tree becomes quite difficult because you can't really be sure where you are in it. So that's the purpose of the next thing, which is the mini-map, and I don't actually have a demo of that, but I can describe it at least. So if any of you played any games, particularly RTS games, real-time strategy games like Command & Conquer, or its more recent offspring, you'll recall that although you're zoomed in on the map, you're looking at individual troops walking around on the field. You usually have some kind of mini-map which displays the whole area and gives an indication of where the current viewport is, that is to say, where on the whole map you are currently looking. So that's the task of the mini-map in this coursework. What you have to do is that you have to have an additional kind of thumbnail view, say up here in the top right for example, which shows the entire fault tree and also draws a box that is the correct dimensions in order to show where on the whole fault tree you are currently looking. And that should obviously be affected by the zoom and the pan that's been applied to the canvas. So where are you looking at the moment? So that's quite a difficult one, so there are lots of marks available for that. So next thing on the list, vector object. Now you should have been using this throughout your labs now, so this is almost a freebie. You should be using your vector object when you're doing your calculations. There should be no sort of stray x's and y's with get x and get y's apart from in your vector object. You want to be using your vector object to its fullest, and you should be able to use all of your vector calculations that we've talked about in the lectures, and hopefully you've already added to your vector object, like add and subtract, scale, multiply, all of that kind of thing. You want to be making use of in your vector object. So coming a bit further down the specification, and we have documentation. So again, I don't have this in my demo here, but what I want you to include in your HTML page is the ability to I haven't really explained that very well, not the ability to, but I want you to include a set of explanations of the various functionalities of your viewer, so buttons that you have to press in order to zoom, or explanation of how you did the various things as well. This should be accompanied by little screenshots as well, include them as image tags maybe. And so yes, in that HTML page that contains the canvas that shows your fault tree view, there should be explanation of how to use it, and also how it works, the algorithms and things that you implemented. Okay, so next on the list, appropriate coding conventions. Hopefully by now you should all be using nicely, properly indented code. It's much easier to see what's going on if all your code is properly indented, much easier to debug. Also, you should be using objects where necessary to encapsulate your data, and meaningful variable and function names. I know variable 1 and variable 2 are not meaningful variable names. So the more meaningful your variable names, the less you'll have to comment, because it'll be self-evident from the code. However, comments should be used where necessary to describe complicated parts, complicated algorithms, complicated parts of your code that bear further explanations. Remember, when you're writing your comments, that you're not writing them for present day you, you're writing them for future you. Maybe 6 months down the line you might not understand exactly what was going on if you look back at your code. You're also not necessarily writing it for you at all. The potential situation is that you write a piece of code that somebody else has to maintain in the future, and so you want to make that as easy as possible. It's kind of a do as you would be done by situation there, because if you were coming to maintain somebody else's piece of code, you would certainly like good commenting. Okay, there's also good use of SVN. You've all been provided with some SVN folders for the module, and I expect you to make use of them. Should not be maintaining the only backups and source control of your software by copying it onto memory sticks, as it's not a particularly reliable way of doing it. So make use of the SVN, be sensible in your log messages as well, so that it's meaningful looking at the log, how you've been progressing, what you've been doing, that kind of thing. So next thing up, oh actually just going back a little bit, I think I may have forgotten to mention, I think I might have skipped the one size does not fit all section. So in case I did, I'm going to go over it again. I want you to be able to display and toggle between both the fixed size canvas that you start with and the resizing of the canvas to fit the window. So this should be a toggleable thing. By the press of a button you switch between the two modes, for example, kind of like a full screen mode sort of, but the canvas should just fit the window. So if the window happens to be full screen, then obviously it's full screen, but if not, then not necessarily. Okay, so I think I may have mentioned that after all, now that I started explaining it, but you have to put up with my absent-mindedness. So moving down to the bottom then, we have self-assessment. So I think maybe a good thing to do would be to actually open up that sheet. So bear with me for just a moment whilst I do that. Okay, so here it is. So supplied in the section which contains the coursework description, we also have this self-assessment mark sheet. Now this is actually the mark sheet that I'll be using as well to mark your coursework. But what you need to be looking at to start with is this column here, enter your marks out of 10. So for each of these mark areas, like using the ARC function for your AND gate or the Bayesian curve for the OR gate, they each carry a certain weighting for the marks. And this weighting is multiplied by this value that you're entering in the column and that I'll be entering in this column afterwards. And for each of those areas, you are marking it out of 10. So say for example, you did the best you possibly could, or the best that anybody could possibly do with an ARC function for doing your AND gate, then you would put 10 in that column. If you didn't do anything with it, then you would put 0 in that column. And then you would scale accordingly between 0 and 10 for how good you think it is. So so you can see how the marks kind of add up from that. In this case, if you put a 10 in that column, 10 out of 10 times 3 would give you 3 marks for that aspect of the coursework. And all the way down at the bottom, it'll generate a total. Now the total will also be displayed. It's out of 100, and there'll be a total that will come out from when I do the marking as well. Now the idea with this self-assessment process is that you should be developing now an ability to look at your work and say how good it is, where it needs improvement, and also be proud of the stuff that you have done well. But that part of that process requires reflecting on the work that you've done and evaluating how it stacks up. So in order to try and encourage you to take this quite seriously, you have an opportunity for possible mark boosts coming up. So when I go through the process, I'm going to end up with a mark, you're going to end up with a mark, and then if it is within 3%, so if my mark is within 3% of your mark, then you'll get whichever mark is the highest mark. So say if I come up and it's, I don't know, 65, and you come up with 68, then you get 68. And equally, if I mark it more generously than you do, then you'll get the higher mark. Well, in actual case, if I mark you more generously than you've marked yourself, you get the highest mark regardless, because that wouldn't be fair otherwise. So you can also see the mark distribution, the weighting for the various different things. So you've got your good use of transformation functions and the various things that you need to add to that. You've got toggling between the fixed size canvas and the dynamic one. The mini-map of the fault tree is quite a pricey item because it's not very straightforward. Zooming in at the mouse pointer again is a fun but complex activity, so that carries some more marks as well. So there's one remaining thing that's down at the bottom of this mark sheet, which is this modifiable fault trees one. Again, I don't have this in my demo, but what would be quite neat is if you could use the mouse to select nodes in your fault tree and to drag them to other fault tree nodes, and so they get replaced as children of the new node rather than the existing node that they came from. So this idea of modifiable fault tree. If you really want to push the boat out, and I would be very excited if you did, then you might have some kind of UI available for adding brand new nodes to the fault tree as well. So maybe have some buttons on the canvas as well that you can drag nodes from. That would be that would be super exciting for me, and maybe feel like stretching your graphics legs. So I think that's just about it really. If you have any questions, then please get yourself on the forums, and we'll try and get some good coursework in here. I'm certainly looking forward to seeing what you can all come up with. So until next time, goodbye.